So looking at our first example, to multiply fractions, remember you're just going to multiply straight across. What I mean by that is that you're going to multiply numerator times numerator, and you're going to multiply denominator times denominator. That should make this pretty easy. So to multiply these two fractions, 2 times 1 is 2, 5 times 3 is 15. And that's all you do to multiply fractions, just multiply straight across. The one thing you always want to make sure is this in simplest form? And in fact it is, so that would be my answer, 2/15. Now, before you multiply, there is a trick you can use, and it's called cross simplification. Okay, what I mean by cross simplification is if there are two numbers diagonal from each other when you are multiplying, this only works when you're multiplying. If you see two numbers that are diagonal from each other that you can divide by the same number, you can simplify before you multiply. What I mean by that is that 2 and 4, I can see that each of those numbers are divisible by 2. I'm multiplying and they're diagonal from each other, which means I can divide them by 2 before I multiply. So I could divide 2 by 2 and have 1, divide 4 by 2 and have 2. Now when I do that, instead of 1/4, I now have 1/2 times, and remember we use this dot, times 2/9. And now when I go to multiply these fractions, multiply straight across, 1 times 2 is 2, 2 times 9 is 18, I get 2/18. And when I actually go to, sorry, I actually did this wrong. This should have been a 1. So I get 1 times 1, which would give me 1 in the numerator. Hopefully some of you caught that as I was going through. So instead of 1 times 2, I really have 1 times 1, which gives me 1, because remember we divided this 2 by 2. So I get 1/18. Now, the whole point of this cross simplification is now this is in simplest form. Let's look at what happened, or would have happened if I had just done 1/4 times 2/9. 1 times 2, multiply straight across, gives me 2. 4 times 9 gives me 36. So I get 2/36, but you all know that I can simplify this fraction by dividing each of the numerator and denominator by 2. 2 divided by 2 is 1. 36 divided by 2 is 18. And look at that. I got the same answer if I cross-simplified first, or if I just multiplied and then simplified, which means I don't care how you do this. To some of you, this cross-simplification may seem kind of confusing, especially since I screwed it up. So don't worry about it. Don't do it. Just multiply straight across, then simplify. For those of you that see this and it makes sense to you, go ahead and do it. I don't care which way you do because you will always end up with the same answer. Looking at the last part of this example, 3/5 times 1/2. Here I have a mixed number, which means I need to convert that to an improper fraction before I can multiply. So I'm going to have 3/5 times, and hopefully you remember how to convert mixed numbers to improper fractions. You take the denominator, multiply it by the whole number, and then add that to the numerator. So I would do 2 times 1, which is 2. Then I would take that 2 and add it to the numerator. 2 plus 1 is 3. So now 1/2 is 3/2. You multiply, then add. So now I have 3/5 times 3/2. And multiplying fractions is easy, just multiply straight across. 3 times 3 is 9, 5 times 2 is 10. We get 9/10. Looking at example 2, we have -3/4 times -3/8. And this is pretty easy. The one thing I want to point out is that when you have a negative fraction, negatives go with the numerator. So negatives go with the numerator. Hopefully you can remember that. You might want to write this down. Negatives go with the numerator. And so instead of having -3/4 times 3/8, I always rewrite them as -3/4 times 3/8. Makes it easier to make sure you don't forget this negative sign or accidentally use it with both numbers. So here I've got negative 3 times 3 because we multiply straight across the fractions, gives me negative 9. 4 times 8 gives me 32. And this is in simplest form, so we are done. Hopefully not too tricky. Just wanted to point out negatives go with the numerator.